Okay, let's go ahead and start going through this. We'll try to get through as many as we can. Okay. Maybe if this is gonna let me write. Come on. Alright, we need to find the derivative. There's probably a couple of things we could do. I think on Friday we saw it where we didn't use the log properties. Let's use our log properties first this time. Okay. So what does division turn into? Nope. Subtraction. So the natural log of x minus the natural log of x squared plus 1. So that what that avoided was that we, on our inner function, we didn't have a quotient rule. Okay. So now I'm going to take that derivative. So what's the derivative of the natural log of x? Good. And the derivative of the natural log of x squared plus 1? Good. And then the chain rule gives us 2x. That's probably where I'd leave it. Could a multiple choice answer make a common denominator? Sure. Okay, but I'd probably leave it like that. Okay. All right. Oh, yeah, make sure you know this one. This is like Mrs. Ballard's favorite. Okay. I think it might have been on the multiple choice too, wasn't it? All right, so we got to find the derivative. So y prime equals, what's the derivative of natural log? 1 over the mess, right? And the mess is the natural log of x squared. And then we got to take the derivative of this one here, which is going to be what? 1 over x squared. And then we got to take the derivative of that, which is going to be 2x. And we could simplify this one pretty easily, and it will be simplified because it'll probably be multiple choice. So x would go with that x. So we would probably see 2 over x natural log of x squared. That's a good problem. All right, we go to 55. Okay. 88, we're supposed to locate any relative extrema, use a graphing utility. I think we did this one on Friday, didn't we? One really similar to it. So, actually, let's skip over that one because I don't have my calculator up right now. Let's keep going, and we'll come back to it, okay? All right, we're supposed to use logarithmic differentiation. That means where you're going to take the log of both sides to start, and then that'll help us get this kind of cleaned up a little bit. So I'm going to take the natural log of both sides. So the natural log of x squared, 3x minus 2 to the 1/2 power over x minus 1 squared. And the purpose of doing that is to make this easier to take the derivative of, because that's a huge mess. You've got a product rule with a quotient rule. That's awful. So by using logarithmic differentiation, we can make that simpler. So what does the multiplication turn into? Addition. So, and I'm going to take that exponent and put it out front. So plus 1/2 natural log of 3x minus 2. And then the division turns into, and I'm going to take the exponent and put it out front. So minus 2 natural log of x minus 1. Now that's not so bad to take the derivative of. What's the derivative of the natural log of y? 1 over y. And notice we always go implicit with this. dy dx. All right, the derivative of the natural log of x squared. And then the chain rule is going to give you what? 2x on the top. Good. All right, plus we've got a 1/2 hanging out. The derivative of the natural log of 3x minus 2 is 1 over 3x minus 2. And then the numerator, what are we going to get for the chain rule? 3. Good. Minus, we've got a 2 hanging out. The derivative of the natural log of x minus 1 is? Good. 1 over x minus 1. And what's the chain rule going to give you on that one? 1, right? So we're just going to leave it. All right, it looks like I could simplify this and this. The other thing I have to do is move this y to the other side. So there was one little extra trick to this. 2x plus 3 over 2, 3x minus 2 minus 2 over x minus 1. Do not try to simplify and make a common denominator. We'd spend all day doing that. Remember how you can't leave it in y? So the trick was, you see how we had what y equals? We plopped that in there for y. Okay, so it's dy dx equals, and then you write your y, which was the x squared, square root of 3 minus 2, 3x minus 2 over x minus 1 squared, and then you put, I'm not going to have space to do it, you put that mess in there. So I'll give you a minute. Get it written correctly on your paper. So get that whole mess written in behind the y. Jump out for just a second. It'll be back. Hang on. Maybe. Probably shouldn't have done that. It's today. It's been super slow. There you go. All right, we good? Okay. Look at the next one. We have to find the indefinite integral. And the first thing we try always is use substitution to see if that works. Then if not, we start using some of our other techniques. Okay? So what would your u be this time? Good. And that means that du is equal to? So that works, right? So I'm going to take this 2 and move it to the other side by making it a 1/2. Because remember, we had some other things. We had the long division, and we had all the arcs, right? But you notice the signs around the room. I put them up there for the BC kids. Okay, but they can work just as well for you guys. You always try that u substitution first. Okay? All right. So this right here, I'm putting in what for it? U. And then for the x dx, we're putting in? Good. All right. And then when we integrate this, we get 1/2 what? Natural log u plus, see, instead of the u, we're going to write x squared plus 1. Done. You hope you get a question like that, right? That one's pretty easy. As easy as it's going to get on those. And remember, you do get to have your chart, right? You don't have to have, the memorized one was last week, so the chart is this week. Okay? All right. This is a good one, too. So star that one. I like this one. Okay? Be very careful. What do you think your u is going to be? Let's try natural log of x. Because look, the inner function is here. The outer function is the squared. Typically, we do grab the denominator. Okay, but watch what happens. So what's the derivative of the natural log of x? And see how that's your denominator? So that's why it is the way it is. So I don't have to do anything except for, let's see, I put a u in for that, so it's u squared. For the 1 over x dx, I'm putting in du. All right, when we integrate this, we get what? Add 1, so u to the third over 3 plus... Don't forget how to integrate, because we've taught you new stuff, okay? Yes, exactly. The more I teach you, the worse it gets. It's really bad. You do it perfectly, and then I teach you something else, and you mess it up. Yeah. It happens every year. All right, we good with 19? Okay. All right. Now, think about this one. And we're doing this natural log stuff, so where's your u probably? In the bottom. So what is your u? Sine theta. This is another really good one. Okay, I like this one. Du equals what then? Cosine theta d theta. All right, so for the sine, I'm putting in u. For cosine theta d theta, I'm putting in du. When we integrate 1 over u, we get? Good. And for the u, we're putting in sine theta. All right, we good with 29? Okay. We did come across this. You're guaranteed to see one of these on the test. Okay, so I'd make sure I knew how to do this derivative of the inverse. Let's see if I remember the formula. So the derivative of the inverse equals 1 over f prime of the inverse of x, I think. Let's double check and make sure. Oh, of a, not of x. Of a. Let's make sure I've got that written down right. We did this. We did it for like a day. And so it's kind of snuck in there. But I want to make sure I have... Yes, I have it written down right. Okay. So that's the little formula you need to know. That one is not on your chart. Okay. So the first thing that I need to do is I need to... what we typically did was we took this and we set it equal to this, and then we swapped the x and the y. So let's try that. So sine of, because we know that the thing with inverses is that we switch x and y. Okay? So I'm going to take that and set it equal to 1/2. Okay? So where is the sine of x in between here and here, right? Quadrant 1 and quadrant 2. Oh, sorry, not quadrant 2, quadrant 4. First of all, where's 1/2 going to be positive? Quadrant 1 or quadrant 4? Quadrant 1. Okay, so we've got out 1, up 0. So let's see, sine would be here. So what's that radian measure right there? So at pi over 6 is where we're looking. Okay. So that means that my coordinate is pi over 6, 1/2. Okay. When I switch x and y, I know that I've got 1/2 pi over 6, right? So that's when I do my swap. So this is my inverse right here. Okay. All right. So we're really looking at the inverse. Okay. So this is what we get when we evaluate the inverse, right? Is pi over 6. So I stick that in here. So f prime of pi over 6. Because I want the y. I want to know what I get when I evaluate it. All right, so I got, now this instruction is saying take the derivative and put pi over 6 in it. So I got to take the derivative of sine. What's the derivative of sine? Cosine of x, and then I've got to throw a pi over 6 in there. So equals cosine of pi over 6. What's the cosine of pi over 6? Yep, square root of 3 over 2, or 2 over square root of 3, or 2 square root of 3 over 3, right? Any of those are good answers. I know, don't circle your answer, but any of those are good answers. But pretty much guarantee you're going to see at least one of those on the test. Okay? Probably only one, but that doesn't mean give it up and don't do it. Okay? All right, let's look at the next one. We got to find the derivative. We like these guys, right? All right, so let's look at 36 first. I kind of threw them both on the same page there. So the derivative of e to the x is e to the x, so e to whatever the mess is, and then we got to chain rule the exponent. So what do we get off the exponent? Negative 2x. Done. And hope they don't ask for a second derivative, right? Oh, I should write a prime on there. 38. We've got to do a product rule this time, so I'm going to keep the first. What's the derivative of the second? E to the negative x, and the chain rule is going to give us what? No. A negative. Plus, keep the second, which is the e to the negative x, and then the derivative of this first is what? 2x. Here's what they like to do, though. That's a perfectly good answer. But if it was multiple choice, they like to do this. They like to take out an x and an e to the negative x, right? So what would be left in this term right here? A negative x, right? And watch what they're going to do with it. They're going to probably put it in the back, okay? And then what would be left here? A 2. I know. But you got to be ready for that. Remember, most of the calculus piece is easy. It's the algebra piece that usually throws us off. Okay? I guarantee it. On the AP test, it's not the calculus. You guys know the calculus. It's the algebra. All right, let's look at this one. We got to do equation of a tangent line to the graph of the function at the given point. Okay. So what two things do I need for equation of a tangent line? Point and slope. I have a point. What am I missing? Slope. So I got to take a derivative to get slope. So what's the derivative of what I've got here? 1 over the mess. Okay. Then we got to take the derivative of this piece. So what's the derivative of that piece? E to the x squared. And then the derivative, the chain rule derivative of that piece is 2x. What's going to happen? E to the x cancels, and I'm just left with 2x. So to get my slope, I've got to plug in -2. So you got 2 times -2 is going to be what? -4. All right, we're going to go into point slope. So y minus what? 4 equals what? Times x minus -2. So it's probably be plus. And again, you may have to distribute. You may have to move that 4 over, so be careful when you're doing that algebra. Okay, it just depends on if it's multiple choice or if it's free response. Okay? All right, we go to 51. All right. Okay, we got to use implicit differentiation this time to find dy dx. So what rule do I need right in here? Product rule. Good. So we're going to keep the first. Derivative of the second would be e to the y dy dx, because we're going implicit, right? Then I'm going to keep the second, the e to the y. What's the derivative of the first? 1, right? Minus, what's the derivative of 10x? 10, and the derivative of 3y would be 3 dy dx, still equals 0. All right, we want to leave everything that has dy dx on the left and move everything else to the right. So I've got this x e to the y dy dx plus 3 dy dx equals negative e to the y plus 10. What are we going to do now? Yep, take out or factor out dy dx. We've got x e to the y plus 3. Likely what they're going to do is switch the order on that, right? Because they don't like the lead negative. Either that or they'll factor a negative out and make the whole thing negative. All right, and then how do we get this mess to the other side? Divide it, okay? We've got 10 minus e to the y over x e to the y plus 3. School party out there already. Rain. All right, we go to 57. Okay, let's keep going. All right, we've got to find. Notice I put the derivative we needed out there. Again, you will have your chart. Okay, you should have them memorized, right? Because we did them the other day. But you will have your chart. Okay. So we're gonna find the derivative of that function. So f prime of x equals. What are you gonna get for it? Natural log of 4 times 4 to the x. This one's, I think, written backwards than the one we had in the book, right? I probably grabbed it from a different chart. The same thing. How do you know what to use? Because 4 to the x, so that your a is a number. Okay. All right. This one here, what rule do I need first? Product rule. Okay. So we're going to keep the first, the derivative of the second. So the derivative of the second falls under this. So what are you going to get? Natural log of 2 times 2 to the t. Okay. And that was keep the first derivative of the second, keep the second. Derivative of the first is what? 2t. All right. Perfectly good answer. Is that going to be what it is, multiple choice?
No.
Not likely. They're probably going to factor something out. So what could I take out of that? 2 to the t and a t, right? You see the t hiding in there? All right, so then we've got, so this here would be left with t natural log of 2 plus 2. And it looks, I think it looks worse that way than it does when you just leave it, but they do kinds of crazy things sometimes. Okay. All right, we go to 39. All right, let's look at this one. So, oh, I don't know why we would use that. Well, I guess let's do, let's take it apart first and then take the derivative. How does that sound? So we don't have a quotient rule that we've got to deal with. So what do we turn the division into? Subtraction. So all I'm doing is some algebra. It's a log base 2, right? Of x squared minus log base 2 of x minus 1. In fact, where should I put this? In the front. I'm going to move it to the front. Okay. So all I have to deal with is the x. All right. So now we have to use this log one. So we're going to keep the 2. The derivative of log base 2 would be what? X natural log of 2, right? 2 is the number, right? It says it's in the base there, so whatever's in the base. Minus 1 over whatever's on the inside, right? So the x minus 1. And then natural log of the base. And then chain rule. Is there anything that, am I going to get anything out of the chain rule there? No. Good? Oh, watch this. Look at what they could do to it. What did I factored out a 1 over natural log of 2, right?
Yeah.
That's pretty nasty, but they could do that. Okay, so be prepared for...
Why do they like to confuse you for your answers?
I don't know.
I mean, you solved it all, but they give you...
I know that you solved it all the way, but they did... I don't know why they do that. Because this is a great answer, right? In the real world, if they gave us a number, we could plug in and solve for it, right? But test writers are funny sometimes. All right, we got to find equation of tangent line. What are the two things we need for equation of a tangent line? Point and slope. Okay, so I've got a point. I need to get the slope. How do we get the slope? Derivative. So y prime equals, I'm going to go right into this right here, right? So natural log of 2, and then 2 to the negative x, and then what is the chain rule going to give me? A negative out front. What do I need to plug into it? Negative 1. So we've got negative natural log of 2 times 2 to the negative negative 1. What's going to happen with the negative negative 1? Cancel, be positive. So I really have, if I were to clean that up, negative 2 natural log of 2 is my slope. So my equation to my tangent line would be y minus, what's the y value of the point? 2 equals my slope times x minus negative 1, so plus 1. Yeah, they could distribute, they could move it over. Not as likely with that funny slope. Okay. I like the funny slope problem though, so that's a good one. All right, let's look at this one here. We got to find the integral, so we're going the other way now. Okay. It looks like we probably want to do a u substitution. Okay, so is it going to be confusing if I use u because there's u's over here, or are you okay with the u? We're cool with the u? Okay. All right, so u equals, and it's not this u up here. All right, so just know that. So u is this negative x squared, right? So du is equal to negative 2x dx. Do you see the x dx? Okay, so I need to move the negative 2 to the other side. All right, let's sub in. So I've got 5 to the u. The x dx is negative 1/2 du. All right, so we're now going to get this. Okay, so we get negative 1/2 hanging out in front. A to the u, so 5 to the u, over the natural log of 5 plus c. And then what do I have to put back in for the u? The negative x squared. So negative 5 to the negative x squared over 2 natural log of 5 plus c. Not likely, but could they do... Oh, not that. That's not what I wanted to write. 1 over 2x 5 to the x squared natural log of 5, something like that. Because the exponent was negative. Oh, there should still be a negative out front. They could do that to you. Not as likely. They don't tend to move the exponent up and down as much, but they could. Okay. Alright, so we've got to find the derivative. We're now into your favorite ones, the arcs. Yeah, most people don't. You guys are kind of the anomaly. Most years don't like these. So you guys have done really, really well at them, so it's good. It's good. That's one question you guys can pick up on that AP test. Yeah. If you can at least kind of recognize the pattern, they aren't that bad. Alright, so we know we've got arc sine. Okay, so we got to take the derivative and it should look like this. Okay. So it looks like f prime of x equals, the 2 is just going to hang out. You go square root of 1 minus whatever's in there for the x squared, right? And then what does the chain rule give you? What's the derivative of x minus 1? 1. That's it, right? That's all you can do with that one. Really, really straightforward. Okay. Alright. Arc secant of 2. Oh, I don't have the arc secant up there. You guys are going to have to help me with that one. F prime of x equals, so what's the derivative of arc secant?
Negative 1 over 1 plus x squared. Right?
I don't think it's negative, is it?
Isn't it the opposite of tangent?
Isn't it negative 1?
No, it's not the opposite of tangent. Tangent, cotangent. It's the
value of u squared.
Negative 1.
absolute value of u, which is 2x, okay. Square root of...
1 minus x squared.
It's the other way around. It's the this goes first. So if I square the 2x, what do we get? 4x squared squared. And then the chain rule piece would be what in the numerator? 2. So now think about this. The absolute value of this would just be 2x, right? Couldn't your 2's cancel? So they would likely give you this simplified. Okay, so be careful. Because like a great wrong choice is they're going to do this to you. Right? Where they leave the 2 off the front. That's a big wrong choice. But it's a good wrong choice. Right? Because it's a big mistake people would make. Alright, we good with 44? Okay. Alright, so now we've got an arctangent. Remember, this is like saying x to the 1/2 power. So we have its derivative. What are we going to write down? It's this one right here.
1 plus square root of x squared.
Squared. Okay, and then for the chain rule piece, what are we going to get? 1/2 x to the negative 1/2. Okay, and I wrote it that way on purpose, okay? These guys, if I was going to simplify, these would cancel, right? So this piece would be 1 plus x. The 2 would be in the denominator, and this would also go down to the denominator, so you'd probably see that as your most simplified answer. Okay. We good with 46? Okay. Alright. Number 2. I think we've only got a couple left, right?
Yes.
Okay. Let's see if we can get through a couple more here. So, if I was going to rewrite that, I'd probably go like this. 1 minus 2x squared, right? So the problem is that our du isn't in the top, isn't it? Is it? But we could put, let's just use a u substitution, okay? I'm going to do a substitution, okay? Oh no, I'm not going to do an a, let's do a b substitution, because all the letters are confusing. All right, so let's put a 2x. So db equals 2dx. Okay. Then I've got 1/2 db equals dx. All right, I'm going to sub in. So 1 minus my b squared. And then I have 1/2 db for my dx. Now, which one of these do I fit? Arctangent, arcsine, arctangent, arcsine, or arcsecant?
Arcsine.
Arcsine, so I'm doing this, right?
Yeah.
So 1/2 is coming from here. Okay, and then we do, either you can do sine inverse or arcsine, your choice. We tend to do this, right? And then u is the b right now, but what is our b really? 2x. So I'm just going to go right to 2x over the a, which is 1 plus c.
Do we really need to put it over 1?
No.
Okay. Will that be an answer?
No, it would not be an answer. Right? The over 1 wouldn't exist. Okay?
Over 1 and 2 is two separate answers.
Alright. What's wrong?
On that one, where did the 3 go?
Oh, we lost it, didn't we? Thank you. Put it in there. Yeah, it was my fault. I was not awake. Even though I've been up, like, I got a wake-up call at 3, and one at 4, and one at 5. The only one that was my actual alarm was 5, though, so. I had the baby alarm go off at 3 and 4. Okay, let's do this one here. So, this one is a little bit weird as well, okay? So, I really have, I shouldn't have put parentheses. It's a square root, not parentheses. So let me erase this. Let's look at the squared. So we have 2x squared minus 1. This is the only one that's like that. It fits this format, right? The problem is I have to have this exactly out here. So what do I need to put in? What's missing? The 2 is missing. So if I put a 2 here, I also have to put 1 up on top. The good news is that I also have to have the derivative in the top, so now I have that set up. Okay? So now, this is a really just straightforward arcsecant. Oh, I don't know why I wrote an integral symbol. Alright, so let's go ahead and integrate it. So arcsecant says we get 1 over a. What's your a right now? 1. So 1 over 1 is just going to be 1, so I don't need to write it down. Arcsecant, u over a. What's your u? 2x, so I'm just going to write 2x over 1 plus c. Yeah, that one was pretty easy. Except that even if you didn't put those in, you probably would have gotten it right. Okay, but technically those had to be there. Okay. Alright, is there only one more?
Yes.
Awesome, we might as well get rid of it and do it, right? Alright, so like I wrote that, it's really 2 squared plus x minus 1 squared dx. I think that that's set up. We don't need anything funny. It's really straightforward, right? So which one is that? Arcsine, arctangent, arcsecant? It's an arctangent. So let's see. We've got 1 over a. What's your a? 2. Good. Arctangent of what over what? Over 2 plus c. All right. I will be here this evening. Don't move it yet. I will be here this evening. I'm going to say 5:45 to 6:30 for you guys. Okay, I know it's a little bit later. Okay. I know we've got some games and stuff going on this afternoon. Okay. Yeah, I know. I will still be here after that because BC is going to be here as well. So I'll be here till 7:15 if you want to stay and study. I'm thinking the test Wednesday instead of tomorrow.
Oh, thank you.
Okay? So test Wednesday, then also don't forget. So tomorrow we will come in and we will do something to study together.
Yes.
Okay?
Yes.
So we will do something to study together. I will try to make sure, I know the multiple choice is already rendered. I will try to get this rendered and out there today. Okay? What else? Oh, there's extra credit on Khan Academy. I think I finally got it fixed and good now. Technically, it's due by Friday. I'll still take it throughout the semester, but whatever you have done by Friday, I'd like to be able to put in for you. Okay?
What?
All right. I will stamp if you want stamps.
Yeah.
You guys can go though.
It starts off with 8, 9, and 10.
8, 9, and 10.
And then it goes in order.
Then it goes in order.
Yes, ma'am.
Okay. 8, 9, 10.
Some of it. Let's do tomorrow.
Okay. That one's technically done the weekends due. That one's done by the test.
The stamps feel so great to hear.
See? And this one's done by the test. Okay. So week 1 is I'll have lots of time to stamp tomorrow. So if you don't want to
those 20 points?
yeah, you'll get the extra credit tomorrow. Okay. All right, that one's there. That one's there. 3 done by test. 4 done by test. 5 done when it's due. All right, you're good to go.
Thank you.
You're welcome.
I didn't read the study guide. Sorry.
This is the hints isn't homework.
No, I know, but I just wrote it.
Okay,
But it's right here.
that
Study
one.
guide.
Okay,
Study guide.
all right, got it. Oh no, let me get that one. Sorry. Okay, Gonzalo, got it.
I have one homework for you.
Awesome.
I have the rest of it. Where did we leave off?